Hey everyone, I'm Evan with First Updates Now. I'm here with Sahej, Joseph, Sean, and Vidhatu from Team 1533 Triple Strange. Today on Behind the Bumpers, we'll be looking at their really unique robot. It's an all-in-one design, has a massive claw for algae, a deep climb. We'll be looking at the design, the system integration, everything, and the controls that went into making this awesome robot. This is a team that was in the pioneers of Swerve Drive and has always been one of the top powerhouses in North Carolina. Sean, if you can go ahead and talk to me more about the design and everything that went into making this robot possible.
All right, yeah. So our main superstructure consists of a pivoting arm on a chain, an extending elevator, and then a pivoting wrist with a dual-purpose algae and coral intake.
All right. So what made you guys go with this archetype? What made you? Because it's so unique compared to anyone else.
All right. So we went through multiple archetypes before we ended up on this one. We were originally thinking of a static arm, but we realized that if we were able to make our arm pivot, we could much more easily integrate our climb without having to add more motors. So we decided on the pivoting arm for that reason. We decided on an elevator so we would be able to score all 4 levels. And we decided on a pivoting intake so we could use it to both score coral and algae. Yeah.
All right. And is this controlled by Kraken's custom gearboxes? What are you using to move all this?
All of our motors are Kraken X60s. We have a custom built 240-to-1 gearbox pivoting the arm. And then we have an entirely internal belt rigging for our elevator. So we have an internal belt path for the elevator, and then for the wrists, our intake and wrist motors are down inside stage 3, and the belts are ran entirely inside the stage 3 tubes up to the pivots.
Awesome. All right, Joseph, if you can talk a little bit more about the climber that's on this thing.
So our climb is a custom design. We chose this design because if we were to use an every-bot climb, it would require a lot of space out, which would interrupt the funnel movement. So we put the elevator into a vertical position. So this is perpendicular to the bars of the cage. And the bars will hit into these, push them down, and get locked into here.
All right.
And it locks by a spring plunger,
okay,
which hits a hole in the side of the latch here. And then we pivot the arm down, and it just creates enough friction where the arm will hold onto the cage, and then we climb. We have these polycarbonate wings on the side of the climb for funneling the cage into it, and they're wide enough where the cage won't get around it and then locked into here, and then stay locked in.
Awesome. This is really unique and low-profile design. Sahaj, if you want to talk a little bit more about the systems integration that went into making this all-in-one possible.
Yeah, so we really believe in systems integration. We have a lot of different things moving on our pivot. I'll go through them. So we have our climb, which is connected to camshafts on the arm, which ensure which is connected to the pivot, which is connected to camshafts, which ensure that the funnel gets at the right position when we're intaking. And funnily enough, our climb is connected to our funnel using a piece of surgical tubing, which ensures that it springs back to the right location. Our intake is also on our pivot.
Yeah, this is super cool. I can obviously tell a ton of work went into this, making it all in one. Vidhatu, if you can talk a little bit more about the controls that went into programming.
We use Choreo and Path Planner for event markers, because this is what we found to work in previous years. We want to try just running straight Choreo like we've seen other teams do, but yeah, that's about it. And then the other interesting thing we've done is with our vision. So right now we're only running one camera, but how we're using that camera is pretty interesting. So early in the season, we saw Mechanical Advantages post on how they had done single tag vision for reef alignment, and we decided to implement their vision on our robot as well. So we found that we've been able to have very little error in our alignment.
Awesome. And so what sensors are you using to control this?
Yeah, so for vision, we're using a Orange Pi with Arduino cams this year because we found that when we had multiple cameras of other brands, we couldn't rename them, so we had a lot of problems with connecting. And then we're using CAN cutters as for all of our encoders. And for zeroing our elevator, we just start checking our current to see if it spikes.
Awesome. And I know you guys mentioned something about a laser on your robot as well. You can talk a bit more
Yeah,
about
so
that.
we're using a banner laser, and we haven't been able to completely implement this yet for this competition. But what we're planning on doing is, in the scoring positions, the laser should hit the reef pole, and we can check if we're actually aligned by checking the laser. What this means is we can get much faster cycles, because instead of having to rely on your vision, or if you have I don't know, poor vision, kind of instead of relying on human error, we just check our smart dashboard. It'll be like, you're aligned, and then you outtake.
Awesome. I can tell a ton of work went into making this all possible. All the integration, everything. You guys are super impressive. This is an incredible robot, and I wish you all the best of luck during the playoffs and the rest of the competition and states and all the rest of the season. Thank you so much.
Thank you.